Hello class, today we're going to be talking about transformations and symmetry of points. So transformations is all about how you change a function. So how you change the shape of it, right? You have what you call a parent function, which is the most simple form of a function, and you can change how it looks. So for instance, we're going to be talking about translations today. And translations is a type of transformation. And what a translation does is it moves a function. So say if I have some parent function, f of x, and let's say it's a quadratic like this. Well, I can move the function left, right, up, and down like this piece of paper to change it. And that's a transformation, and specifically a translation. So I can move it like this. Try to draw it just as similar. Just like that. And so you can see that it shifted down from the origin down to the point, what is that? 4, -2. Okay? So this one we'd say it translated right 4 units and down 2 units. Something like that. But today we're not going to talk about it graphically, we're going to talk about algebraically. So you'll be given a function, something like this, and you'll want to be able to identify how it's being translated just based off of looking at the function itself. And it's really not that hard. So let's take a look at the general form. We have f of x is equal to x minus h to the n plus k. N could just be any number. It's just whatever your function is raised to. Like this is second power, third power, so on. But it's h and k that we're concerned with. H moves or translates the function left to right, and it's read as the opposite sign. So for instance, if it says -2, it's really going to the right 2 units. Or if it says +2, it's really going to the left 2 units. K is a little more straightforward. It moves the function up and down, and it's the same sign. So a +2 would be up, and -2 would be down 2 units. And another little note, H will always be in parentheses. That's how you know that what is an H and what is a K. An H will always be in parentheses. A K will never be in parentheses, okay? So if you ever had to have like some of them look a little funky like this, where it doesn't exactly look like the general form, just note that if it's in parentheses, it's an H. If it's not in parentheses, it's a K. All right. So let's go over some examples here, and I want to know. I want to list the transformations that I need to move f of x over to g of x. Now, f of x are the parent functions. I told you it's the most simple form of a function. Nothing's happening to it. It's, well, this is the most simple form of a square function, right? But it's not like it's being shifted or moved up and down, left or right or anything. And I want to know what transformations or translations take it from f of x to g of x. Well, let's identify what our k and our h are here. Well, I know that my h will always be in the parentheses. And, well, this looks exactly like it, right? So this is my h. So h, and then 4 is my k. So h, I said, moves left and right, but it's the opposite sign. So our h, I'll write it off to the side, our h is -3. Well, no, I don't like that just yet. Okay, so h is the opposite sign. So if it says -3, we're really moving to the right 3 units. And if it says +4, we're moving up 4 units. So our answer here would be it's translated 3 units right and 4 units up, just like that. That's how our answer should look in these cases. Okay. Moving on to another example. Here we have f of x is equal to x cubed, and we have this g of x is equal to x plus 2 cubed minus 1. So again, let's just identify what our h and k are. Our h is 2, well, is that 2, and our k is that negative 1. So this one, we'd say it's translated 2 units left, because it's the opposite sign. Generally, positive means to the right, but when we're talking about our h's, it's opposite sign. So a plus 2 really indicates that it's moving to the left 2 units. And then this minus 1, that's the same sign, because k's are the same sign, and down 1 unit. Okay? And that's that. Now, this example, I pointed out earlier, it doesn't necessarily look like our general form up here, does it? We don't have any parentheses. But when that's the case, that just means that our h, which is inside the parentheses, is equal to 0. So it's not moving left or right at all. In fact, it's only moving down. And how do I know this is a k? Well, k's are always outside of the parentheses. There are no parentheses, so whatever you see is a k. Okay? That was a good one. Okay. So this one is just translated down 3 units. Okay? And we don't need to mention if it's translated left or right, because it's not, so you can just leave it out. You don't have to say translated left or right. 0 units. That's a little extra. Okay. Now this one, we have f of x equals x squared, and g of x equals x plus 5 squared. Well, again, we know that we know that h's are always in parentheses. So this is my h. Now, I don't see a plus or minus anything outside of the parentheses, so in this case, k is 0. Just like how up here there's nothing in parentheses, which meant h was 0, nothing outside of parentheses means that k is 0. So, and we don't need to mention if it's moved up or down at all, because it's not. So this one is translated 5 units. Remember, when it's inside the parentheses, when we're talking about our h, it's opposite sign. So plus 5 actually means left 5. That's not how you spell left. Okay. Translated 5 units left. And that's that on translations. So let's go on to the symmetry of points concept that we're that's in the title here of this 1.5. So symmetry of points. Symmetry is just how things are alike given a certain certain line of reflection. It's essentially just a reflection of itself, right? The reflection of you in the mirror is symmetrical to yourself, right? So on the worksheet and on the test, you'll be given something like this. You'll be given a graph, and you'll be given a point. And you'll be asked to give the coordinates of another point so that the 2 points are symmetric about the x-axis, and about the y-axis, and about the origin. So let's just recall this vertical one is our y-axis, the horizontal is our x-axis, and the origin is right in the center here. So let's start with the x-axis. Well, the x-axis is right here. So when you're talking about reflection, imagine like flipping over your paper or something, so that about the line of reflection. So if this is -3, -2, it looks like I would have to go to -3, +2 in order to get a point that is symmetric about the x-axis, right? So my answer here is going to be my new point, negative 3, positive 2. Now what about the y-axis? This is the y-axis, so it would be going this way, like this. So it wouldn't be at negative 3, negative 2. It would instead be at positive 3, negative 2. You see how it's the same distance away from the y-axis? So this would be positive 3, negative 2. And then what about the origin? Well, the origin is in the center. So if it's 3 to the left, 2 down, it's instead going to be 3 to the right, 2 up. Something like that. So it's just going to be the exact opposite. Oh, forgot that. So this is going to be 3, 2. Let's go into this one, and then we can make kind of like a general statement about this. So you can just do it algebraically instead of necessarily having to look at the graph. So again, give the coordinates of another point so that the 2 points are symmetric about the x-axis. This time our point is at point 2, 4. So the x-axis, let's see. The x-axis is, let me label it again, just so we have it, is the horizontal axis. So it needs to be the same distance away from the x-axis, but on the other side. So that would mean it would go down here. So that distance of 4 is going to be not a positive 4, but it's going to be a negative 4, and the 2 stays the same. So our point's going to be 2, comma, negative 4. Now what about the y-axis? Well, the y-axis is the vertical one, so it needs to be that same distance away, but on the opposite side. So it looks like it's going to be right here, which means that it would be at negative 2, 4. And then finally about the origin. Again, the origin is the center, so if from the origin we're going 2 to the right, 4 up, we're going to instead go 2 to the left, 4 down, and it's going to be right there. So it's going to be negative 2, negative 4. So we're just labeling the points. That's all it's asking. We're not solving for anything here. But let's just kind of make a general rule. Because you may have noticed a pattern here. When we're talking about when we're trying to find a point symmetric about the x-axis, what we did was we actually changed the y value. Notice it was negative 3, negative 2. Now it's at negative 3, positive 2. You just changed the sign. This was 2, 4. This is 2, negative 4. So general rule, symmetric about the x-axis, change sign of the y value. And then notice when we reflected about the y-axis, we didn't change the y value this time, we changed the x value. See how negative 3 turned into positive 3, and positive 2 turned into negative 2, while the other one remained the same. So that's going to be the rule always. So symmetric about y-axis, we want to change the sign of the x value. So you just change the sign of the opposite one. If it's x, you change the sign of the y. If it's y, you change the sign of the x. And then finally, if you noticed about the origin, we're changing both signs. So negative 3, negative 2 turned into positive 3, positive 2. And 2, 4 turned into negative 2, negative 4. So symmetric about the origin, change both signs. And that's how you do symmetry of points. So that's it. That's all I have for y'all. Let me know if you have any questions, and have a great day.